Hello, this is Cameron Owens from IdeaGarage here with another tutorial on how to get started with electronics. Today we're going to be talking about the HC-SR04 Ultrasonic rangefinder sensor. This is a sensor that allows you to sense the distance from the sensor to a physical object using sound. The way that this works is there are two transducers on the sensor itself, one of which is responsible for generating a sound, the other for which is responsible for listening to that sound. Now, if you're not familiar with how speakers or microphones work, it's important to note that they are basically the same object. One just works in reverse relative to the other. So here I've got a little 8 ohm 0.5 watt speaker that I've used on various other projects. Now, there are three primary components to a microphone or a speaker, one of which is going to be a membrane, which is responsible for vibrating and either generating a sound or receiving the sound. The other component is going to be a coil of some sort, a conductive coil inside the membrane. Now, this is going to be responsible for either generating a magnetic field or generating a current. And then you have a magnet, which is just responsible for generating a magnetic field. What happens when we operate this as a speaker is that we apply a voltage at a particular frequency, which then causes current to flow through the coil in here and generate an alternating magnetic field, which then causes that magnetic field to be attracted or repulsed by this magnet. When that happens, you get small little vibrations in this membrane, which then generates sound. Now, a microphone works on the same principle, but in reverse. Sound vibrates on this membrane, which then causes a current to be generated by passing a conductor through a magnetic field, and then we can then sense that coming out on these leads. Now, that's a very basic understanding of microphones and speakers. If you want to understand more of how these work, strongly recommend just checking out on the web. There's lots of other great tutorials and resources on the matter. But today we're going to be talking in particular about how to use this sensor in your electronics and robotics projects. Now, as I said before, we're going to be using sound. Sound travels through air at a particular speed, or the speed of sound. Now, the speed at which that travels through the air is highly dependent upon two factors, one of which is going to be temperature, and the other of which is humidity or density of the air. Now, both of those are interdependent, meaning that one can directly affect the other. So if we go over to Wikipedia and we take a look at the speed of sound, and we scroll down to the real core of what we're talking about today, you can see where these calculations for determining the speed of sound through dry air can be calculated from. And you'll see that temperature, here we go, so where V naught is the temperature in degrees Celsius. So here is the very basic form of this equation that we're going to be using. Now, in the code, I've simplified it down to the basic expression using the assumption that it's going to be 20 degrees C, which is about 70 degrees Fahrenheit in there. You can read more information. There are general lookup tables, so you can say, oh, if it's say 35 degrees C, here's what the speed of sound is for a particular density of air. Now, in future tutorials, I'll be integrating this sensor, which is the DHT22 sensor, which allows me to sense what temperature it is, as well as what the barometric pressure is. So if you grabbed any of the code from the link provided below, which takes you to our GitHub page, not only will you get the code for this project, but you'll also get a 3D model for a little case that you can print to house the sensor. This sensor just fits in here with a little press fit fitting where the transducers hold it in. You just pop it in there, holds it in there, and then it gives you access to the 4 pins to be able to wire this up to your Arduino. There are 4 pins on the back. You've got ground, echo, which is responsible for sensing the return signal or the return sound. You have trigger, which is responsible for generating the sound, and then you have VCC, which is where we apply our positive 5 volts to power this. So you can either connect DuPont wire to there, or you can just solder them directly. And then part of that model that you can download is the back, which the wires just come out of here, and then you use M3 socket screws to screw it together. So here on the bench, you can see I've got a ultrasonic sensor that I've put right at 0 of my ruler, and then a box right at 12 inches. And in the code, which I've provided in the sketch for this, what it does is it will do a calculation and provide both the distance in centimeters and in inches. Now, because it is a particularly cold day and it's a little bit chilly here, I haven't tuned the calculation, because it's a very generalized calculation, to be based upon my temperature here. You can see that there's a little bit of error. On the serial output, I'm reading at 11.84 inches. And that error is most likely due to the temperature being a little bit cooler here than the generalized 20 degrees C. So in the future, we'll be doing another tutorial in which we integrate this into our Arduino to also fine-tune the temperature to fine-tune the sensor to have a much more representative distance for that. So hopefully this will provide you enough information to kind of get started. Please check out our GitHub page where you can download the source code used in this demonstration, as well as the model to be able to 3D print a case for your sensor. We'll be using a lot of this to build our ROS-powered robot in the future. So if you're wanting to build a little low-cost robot powered with ROS, stay tuned for more to come. Thanks.